Okay, let's dive in. Imagine the headlines flash. Military strikes hitting nuclear facilities. Your first thought might be, fallout. How far away do I need to be? What's the actual risk radiation could reach you? That's exactly the scenario we're unpacking today. We've got a stack of source material here, reports, assessments, expert analyses, all focused on a hypothetical but very seriously considered possibility. Military strikes on Iran's nuclear facilities, maybe June 2025, and specifically the potential radiological risks for nearby regions, like the Caucasus. So our mission in this deep dive, cut through the noise, get specific. What do these sources actually say about the radiological risks? It might be a bit counterintuitive, and look, the politics are incredibly complex, we know that. But we're staying strictly impartial here, just focusing on the facts presented in this material.
Right. What's fascinating is the scenario these sources detail. It involves an Israeli air campaign, June 2025. This is after diplomatic failures, IAEA censure. But the really critical detail the report zero in on is what was targeted.
That seems absolutely key, doesn't it? Sources say uranium enrichment and conversion facilities, places like Natanz, Isfahan. But crucially, and the sources are explicit, nuclear power reactors like Bushehr or the heavy water reactor at Iraq, they were not hit.
Exactly. And that distinction, according to these analyses, it just fundamentally changes the nature of the threat compared to, well, what most people probably picture first. This is not a Chernobyl situation, not a reactor meltdown releasing, massive plumes of volatile fission products, causing immediate, widespread gamma radiation danger.
Okay, so reading this, that was the big takeaway for me. The risk isn't about getting blasted by gamma rays from some damaged reactor core miles away.
Precisely. The risk, as laid out in these sources, stems from the kinetic destruction. Basically, bombs and fires hitting facilities that handle uranium compounds.
Which then aerosolizes the material, throws it into the air.
Yes, exactly. It turns these uranium compounds into really fine particles. And this is where the sources stress the hazard becomes primarily internal. It's about breathing in or ingesting these tiny particles. They contain long-lived alpha emitters. If they get inside your body, the concern is a potential small increase in the long-term statistical risk of cancer. Very different hazard profile. Maybe think less Chernobyl, more like the concerns around dispersed plutonium from incidents like the Rocky Flats fires, though even that's an imperfect comparison.
Okay, so the worry is breathing those particles if they travel. Which brings us to the next question the sources tackle. How does this stuff actually get out, get airborne, and potentially travel hundreds of miles, say, to the Caucasus?
Well, the initial explosions and fires, they can loft particles. The sources even get into specific chemistry. If uranium hexafluoride UF6 is hit, it can react to form toxic hydrofluoric acid gas, and radioactive particles of uranyl fluoride shows the complexity. But interestingly, IAEA findings mentioned in the reports noted contamination inside damaged buildings at Natanz, yet monitoring outside the site showed radiation levels stayed, well, normal right afterwards.
Right, so based on those initial findings, the immediate blast fallout wasn't necessarily the main worry for downwind regions like the Caucasus.
Not the primary one for immediate widespread impact mentioned in these specific sources, no. The concern highlighted for areas further away is more about potential resuspension later on, meaning particles settle, then get kicked up again by wind or human activity. Atmospheric modeling, like HYSPLIT simulations they reference, shows plumes could reach the Caucasus region over several days, carried by higher altitude winds.
And when this plume, potentially carrying resuspended particles, gets there,
then the Caucasus Mountains themselves become a major factor, particularly through something called wet deposition, basically rain or snow washing the particles out of the air. This doesn't create a uniform blanket of contamination. Instead, you get these unpredictable, potentially quite localized hotspots.
So, zooming in on Azerbaijan, right next door, what did the sources suggest are the potential consequences there?
For Azerbaijan, the sources point to, yes, an environmental contamination risk, particularly in southern mountainous areas due to that deposition, but they also highlight something potentially more disruptive: severe economic impacts, especially for agriculture, driven largely by the perception of contamination, even if the actual measured levels are quite low.
That's where it gets really complex, doesn't it?
Yeah.
Beyond the pure science, the human reaction.
Absolutely. And on public health, the sources are clear. Zero risk of acute radiation syndrome, that immediate radiation sickness. The concern is that potential low-probability long-term cancer risk from internal exposure, especially noting children and fetuses, could be more vulnerable. But again, the psychological impact, the fear, the uncertainty is stressed as a massive public health challenge in itself, maybe even overshadowing the direct radiological risk in terms of immediate societal disruption.
and Azerbaijan's capacity to handle this based purely on these source materials?
Well, the sources mentioned they've shown they can monitor their borders, mobile teams, automatic stations detected nothing elevated immediately after the hypothetical strikes. So detection capability seems present. However, they also reference a 2024 WHO assessment that flagged a significant gap, scoring only 20% in capacity for actual chemical and radiation decontamination.
Ah, so a mismatch there. They might see it coming, but dealing with it if it lands.
That assessment suggests limitations in the cleanup capacity, yes.
Okay, so wrapping this up, this deep dive into the sources paints a picture of a radiological risk that's real, but very different from a power plant disaster. It's a long-term internal exposure risk, potentially localized, heavily influenced by things like weather patterns, and hugely complicated by fear and economic fallout. Understanding that specific nature of the threat, distinguishing it from Chernobyl, seems absolutely vital for any kind of informed preparedness or response based on these reports.
Yeah, it really underscores how these modern crises, even involving nuclear materials, have these complex, interconnected risks. It's not just the obvious plume you might first think of.
So the final thought these sources leave you with: the strikes might not cause that immediate large-scale disaster scenario, but maybe they reveal a different vulnerability. The challenge of managing persistent low-level contamination, and perhaps even more so, managing the powerful disruptive force of fear in an already volatile region. What does this specific scenario tell us about preparing not just for the bang, but for the long, complicated aftermath? Something to think about.